The first electric cars can be traced back to as early as the 1830s. Flash forward to 1900, and astonishingly, electric cars make up about a third of the cars on the road. But electric vehicles that were once leaders of innovation became a faint echo of the past, overshadowed by their gas-guzzling competitors. But what caused this radical shift? What happened between then and today that caused the electric car to lose its charge? How did the electric vehicle go from a third of the market to a fraction of a percent a century later? Luckily, electric vehicles are making a triumphant comeback due to decades of innovation. And as we embark on this resurgence of electrification, we are seeing this investment impact more than just the automotive market. We're seeing the electrification of planes, boats, school buses, even cargo ships. Joining us today are Gregory Davis, CEO of Eviation Planes, Mitch Lee, co-founder and CEO of Arc Boats, and Duncan McIntyre, founder and CEO of Highland Electric Fleets. So we've got planes, boats, and buses, and together we discuss the breakthroughs that have set us on this path, but also what can and can't be applied to these new applications, cost curves, and moats. And by the way, if you don't think this will happen quickly enough, I'd like to point you towards two pictures taken on Fifth Avenue on Easter morning. These pictures were taken 13 years apart, the first in 1900, and it looks like a Waldo puzzle where you're actually trying to spot the car amongst this sea of horses. But just 13 years later, in 1913, Spot the Car really turns into Spot the Horse, where you see one horse amongst a sea of cars. And I think this is just a testament to just how quickly technology can change things. So, buckle up, folks. Welcome to the electrification of everything. As a reminder, the content here is for informational purposes only. Should not be taken as legal, business, tax, or investment advice, or be used to evaluate any investment or security, and is not directed at any investors or potential investors in any A16Z fund. Please note that A16Z and its affiliates may also maintain investments in the companies discussed in this podcast. For more details, including a link to our investments, please see a16z.com/disclosures. I am so excited about this conversation because I think many people are familiar with the electrification of passenger vehicles, right? Some of the biggest companies in the world now are tackling this and have been tackling it for many years. But I guess as a carryover from that industry, we're seeing the electrification of many more things, which I think people are maybe a little less familiar with. And so I'd love to hear from each of your perspectives. What got you into this industry? What got you fixated on this idea that you needed to electrify a new industry? And so why don't we just kick things off with you, Greg?
Thanks very much for the question. I mean, the idea of electrification in aircraft has been around for quite a while, but my involvement in this actually went back to something I was doing in about 2017, 2018, looking at ways to see how the new technology, the new engine technology that was being developed could be used to reduce the carbon impact of aircraft. The sustainable aviation industry is still quite young, but it's being born out of the fact that we know we need to do something about it. So what I mean is that right now, aviation contributes about 3% of all world CO2 emissions. But our own industry projections are that by 2050, that's going to be anywhere up to 50% of all CO2 emissions everywhere. And it's because that technology evolution hasn't happened in the aerospace industry the way that it has in, say, for instance, the automotive industry and some of the other great industries that we're going to be discussing today. And I absolutely love aircraft. I think it's so important from an economic and from a social perspective that we can continue to connect communities, but we can't do it while we're harming the environment. And what really attracted me to aviation and this opportunity that's here right now, what we're specifically working on, we have an aircraft that's going to be able to really change the way that we fly. The cost efficiencies of operating on electric power, the noise reduction from having the new engine technology that we've got, again, that elimination of carbon pollution makes it cost-effective, convenient, and also carbon-free to connect communities. And I just find that very exciting.
I love that because I think maybe one aspect that people pay attention to for good reason is just, is it electric or not? But what you're pointing at is that electrifying an industry or a product also has other ramifications, like you said, noise pollution. Could also be, the ability to move that energy back into the grid in other ways. And so, Duncan, you're working on school buses, which is a whole nother industry. And so tell me a little bit more about how you decided to venture into this space.
Sure. I think Greg hit on one thing that's near and dear to me, which is noise pollution. I think when I think of electrification, I think of it as an upgrade all around. Maybe a third to half of the folks that we engage with commercially are interested in talking about climate change and CO2, but more than half of them, if you start the conversation that way, the conversation's over. But if we can frame it in a different way around being an upgrade, they're cheaper to operate, cheaper to fuel, fewer moving parts, they're cheaper to maintain, they are very quiet, they help attack poor air quality in urban areas. Transportation is local. No matter how you slice it, it's a local dynamic. Local politicians are, awarded their seats or rejected from their seats based on topics like this. And so you have to get into the local side of it to win. But more than anything, I think, Tesla inspired us all to look at the EV as technology that's here now. And it's not only here, but in many cases, it's better. It's an upgrade. It took the market a little while before the product was developed to do medium and heavy duty. And we're there now. Companies like Daimler are producing medium and heavy duty platforms, electrified platforms. And so we started Highland focused on the school bus market because we saw the demand. And we also saw the duty cycle as being really appropriate for what electrification had to offer. But we're entering the trash hauling space. And we're getting into basically any form of municipal and government operated vehicle that tend to operate in a fleet format. And so for us, it's about making sure that it's reliable and affordable. And our product suite stitches together the capital infrastructure, the services needed. And I think about it as 12 to 15 small businesses that have to be stitched together and completely seamless to the customer. And when that's done at scale, it's not only affordable, it's just cheaper for cities to run electrified fleets. So we're really excited about it. And I saw that sort of opportunity to innovate around business models and drive commercial adoption.
Right. To make it a no-brainer, right? Again, not just the electrification, but to just make it the obvious answer. Mitch, you're tackling boats, which is, again, like a totally different line of products, but maybe with some parallels. And so would love to hear how you got into that. And as both Greg and Duncan have mentioned, it feels like you can almost piggyback off of the automotive industry or the strides that have been made there. And so tell me about how that has maybe also applied to boats.
Yeah, so I come at this from a very personal level. I grew up on boats. My parents were huge water skiers, and I grew up as somebody that loved being out behind a boat on a kneeboard and water skis and wakeboarding and eventually surfing and inner tubing and just enjoying the water with friends. But gas boats are so much fun to be on and an absolute nightmare to own and awful for the environment, particularly when it comes to not just air pollution, but water and noise pollution. Electric boats are just better boats, and they make a ton of sense. I like to think that, or say that in the auto industry, gas cars were actually pretty good at what they did. They're quiet, they're reliable, they have relatively good fuel efficiency. Electric cars are still an upgrade, but when you look at the boating industry, the pain point of boat ownership is so much more visceral. These are boats that are stuck in the 1980s technology. They're basically like oversized gas lawnmowers. They're loud, they're noxious, they are unreliable, they run out of gas on you. And when you compare that to what you get in an electric package, it's such a better experience. Reliability goes way up. You can enjoy conversations on the boat when it's whisper quiet. The torque that you get pulling somebody out of the water is better. Even the experience of refueling gets to be so much better because boats are kind of a point A to point A sort of vehicle. So that makes charging a lot more tractable. Electric boats are a very obvious idea and a huge improvement from a customer perspective. The hard part is the execution of this. They're so power hungry. And that's where we have really benefited from hundreds of billions of dollars that have gone into research and development in the auto industry and the supply chains and the battery technology that's powering the auto industry that has suddenly enabled us to go tackle the marine industry, which might not by itself have been able to support that volume of research and development. And that's what gets us really excited, because what we're doing today was not possible 5 years ago. But what we're doing today is also such a better product experience compared to what exists today in the market.
On this idea of borrowing from the auto industry, I'd love to hear from all three of you what aspects were really easy to port over, where you could say, look, this innovation has, been worked on for a long time and I can kind of copy and paste it to my industry. But then also, what required you to create something net new? Because it is a different product line. There are different considerations, whether it's being on the water or having to be in the air or having additional redundancy because you're in the air. And so I'll just kind of leave this open to the group. What have you had to consider and reinvent versus what has, again, been able to be, borrowed from the existing automotive industry?
All the technology development around making the electrified powertrain super efficient, right? This is your electric motor connected to, your batteries and all the high voltage systems that need to exist in the balance to make it work. And, Mitch talked about reliability. Couldn't agree more. Electric is awesome because it is so reliable. That is an area that we probably all benefit from, is just years and years and years of making it a super durable system. I would say for us, we had to create a ton of interoperability systems that we didn't expect we'd have to build. And what I mean by that is not all charging stations work with all vehicle types. There's firmware, there's other battery management software within your vehicle, and then there's the utility. And if you think about creating a reliable ecosystem, all of us, Mitch said power hungry. They're really power hungry, right? Our depot in Bethesda, Maryland, draws 5 megawatts of power when we're charging. It's the largest electrified depot in the country, running 200 school buses. And 5 megawatts is like 5 hospitals coming online overnight. And so you need really advanced software that is managed in a way that we've never had to do in the past, here in the States anyways. And that's interoperability between your chargers, your utility, your vehicles. And if you're going to make the overall experience reliable, the vehicles are reliable when they're out running, but if they're not reliable when they're charging, you have a major problem. And so that's maybe the biggest thing we've had to do far more creation around than I expected.
I can maybe piggyback off of that specific to power requirements. Boats are power hungry. And to give you some scale, recreational boats use more gallons per mile than a fully loaded semi-truck. A fully loaded semi-truck might get 6 to 8 miles to the gallon. A boat gets 1 to 2. The amount of energy you need to store on these boats is pretty large. The Arc 1 has 2 battery packs totaling 220 kilowatt hours of battery capacity, which for reference is well over twice the size of any car that you'd find on the market today, like a Model S or Model X.
It's identical to what you put in a full-size school bus that hauls 78 children around.
Exactly. And so one of the biggest challenges is just packaging that much capacity and building battery packs at that size. And then on the boating side, and I'm curious to hear Greg's take on this, but on the boating side, we have a very high continuous power draw. So in the auto industry, what you see is your power demands kind of spike as you're accelerating 0 to 60. That's where you draw a lot of power. Once you're up to 60 miles an hour, the continuous power draw tends to be much lower. Boats almost have the inverse curve where your power draw is, you don't necessarily have very high peak power because it's actually hard to put a lot of power into the water. You're limited by your propeller. Instead, what you have is very high continuous power, because going 40 miles an hour through the water, which is viscous, is much harder to sustain that. And so that generates a lot of unique challenges for the marine industry, or for our application of electric technology to the marine industry, particularly around how do you cool that when you're generating so much power, and how do we make our motors tolerant to that amount of power draw. And again, Greg, I'm curious your take on this from the aviation
Greg
side.
needs 20,000 times more power than we do to get a plane in the air.
We you know what? It's actually, the comparisons are really interesting. I think I'm going to start by highlighting a few differences just to sort of lay it out there. Each of our battery systems is actually designed to different criteria. So that where we've benefited from automotive is the advancement of the cells, right? So there's a definite benefit for improving the energy density, or the what we measure in watt hours per kilogram at the cell level. But the architecture of our systems is going to be unique for each application. So I'll give you some practical examples of why that is. When you're building a car, or Duncan, I get your opinion on this. And Mitch, I think it'd be fun to sort of fact check here on air. But when you're building a car, ground-based vehicle, the typical consumer is involved in buying that car. And when they buy an electric car, they don't want to think about things like having to replace the batteries while they own the car, right? You want the car to last through the entire time that you buy it. I would say my guess is that the marine industry is a little bit more forgiving than that.
They are.
Okay, yeah. And the aerospace industry actually expects to have to maintain your aircraft, right? So when we're designing our batteries, we're actually designing them to a specific life cycle. And so the battery replacement, the quality of the batteries in an aerospace application it's obviously very, very high, but it's also governed by the certification standards that we're going to have for the aircraft. Part of our advantage at Eviation is that our whole product, the premise is based on the fact that we're able to design and certify an airplane using the existing standards. So we actually have a clear path to certification. But, we design our batteries to be replaced every 3,000 cycles, which given our utilization is about every 3,000 hours. So that could be 2 years, 3 years, 4 years, depending on how you're going to use the airplane. But the great thing is that the battery technology continues to evolve. And so our architecture is designed so that it can actually be I'll say somewhat agnostic to the actual cells that are being used to provide the energy. So we can upgrade our battery every 2, 3, 4 years. So when you go in and you do a mandatory maintenance activity, which is absolutely normal for an airplane, you actually end up getting a better plane.
I want to chime in there because I think it speaks to how different the problems are for each of these industries. We have an entirely different scenario, which is a big boating season is maybe 50, maybe 100 hours. We are the opposite of cycle constraint. You will never reach a point where you have outcycled the useful life of your battery, because even with a ton of usage on that boat, it is nowhere near what you would see in an auto industry or in the aviation industry.
And one final thought is what we really should get to as an industry is, Gregory uses these batteries for 2.5 years, and they're no longer, suited to the standards that you need, but they're perfectly fine for me. They roll off and they're in applications that are less mission critical, where they're still perfectly safe and they've got a perfectly good life. That's ultimately a better design than, not to the extent that Mitch explained, but our school bus fleets are on the road 9% of the hours in a year, and the other 91% of the time they're sitting idle. So they're actually relatively underutilized.
On that note, I'd love to hear from especially you, Duncan, and Mitch, because these assets, actually, I guess the plane this is true for as well, but for some period of time, they're not being used, right? And so that influences when you can charge, how much you can charge, but also something that we're seeing a lot more with even the passenger vehicles is the idea that some of this charge can go in the reverse direction, getting more use out of the asset itself. And so would love to hear your thoughts on, again, this idea that the electrification of these products is not just gas to electric, but it opens up this whole range of other potential opportunities.
Yeah, look, it's a good question. It's core to our business model at Highland. And about half of our projects today are backflowing power from our fleet of batteries to the grid when the grid needs the power the most. And we earn various amounts of money, but in New England, as an example, we earn about a third of our revenue.
Wow.
Just from providing grid services. It's a battery just like any other stationary battery, and it can be used to absorb high levels of renewables production and help meet the grid's demand during the grid's peaks. And so it's a very interesting opportunity for, frankly, all of us. All of our industries are power hungry. And if we charge at the wrong times, it's going to make operating the grid much, much more expensive. And so I think we see it as an issue that is getting solved, but too slowly. Ultimately, the utilities and the wholesale energy markets, we think, should develop better products and then better policies too, to sort of really require that this activity is done smartly. Because if it's done in the right way, you're going to flatten the load curve and drive better efficiency in our distribution system and our generation systems, as opposed to the opposite.
So we come at this from the more localized customer perspective. Duncan's coming at it from the grid level, which is very exciting because when you stack multiple of these vehicles together, you quickly get into the megawatt hours of capacity. We think about it from two perspectives. The first is the fact that a normal boat outing might be 4 hours out on the water. What that translates to is 20 hours of downtime that you can then go recharge before you would feasibly be using that boat again. And so it makes charging a much more tractable problem, where if a boat's at a dock, you have plenty of time for an overnight charge before you use it again. You don't necessarily need fast charging to exist in order to have a compelling electric boating experience. And then the second part is, that boat is sitting in the off season when it's winter and it's too cold to go boating, or even midweek when you're working and not able to get it out. That's an opportunity to provide power back to your house. So again, not necessarily at the grid level, but that is a tremendous amount of battery capacity that could power your house for a week without you doing any sort of finagling of electric loads. And that's exciting because it presents a whole bunch of opportunities to optimize your energy consumption throughout a given week.
It's funny, I was just talking to one of my board members, a guy named John Meskel, about this exact same thing. And what we've just highlighted collectively is how well this technology, the battery technology, electric technology, integrates into the way that we actually use things. The primary and secondary uses of the aircraft, each of us is looking at the charging network, right? So the infrastructure, but not just at the infrastructure level, also at the actual vehicle interface level. And certainly our discussions about the charging network absolutely include the idea of secondary storage of energy. Typically speaking, the aircraft's going to fly, morning to evening. Cargo applications will be able to use it later in the evening, which isn't directly related to batteries. It's actually related to the fact that the aircraft's so much quieter that it's not going to be subject to noise restrictions. But when you look at the typical turnaround time for an airplane, the aircraft, you load passengers onto it, it takes off, it travels for an hour, it lands, and then you offload the passengers and baggage and then repeat the cycle. That turnaround time typically takes about half an hour. You can charge your batteries for 1 hour of flying time in 30 minutes. And that's actually a fairly gentle charging cycle for a battery. So you have the opportunity for using fast charge and megawatt chargers and all this. And those will be part of our solution for some applications. But compared to some of the more strenuous applications on batteries, we're actually being relatively gentle to what we're doing with our batteries, even at the aircraft level. And that's actually, again, very, very exciting. So, with today's available energy levels, energy densities that we can get from batteries, with the projected efficiency gains that we're going to have as the systems develop, You can actually take that technology that's very clearly in front of us in the next 2, 3, 4 years and design it right into your product. It's a great fit.
Yeah, Greg, will you provide charging solutions with the planes? I would imagine your business model is to sell equipment to operators. Is that right?
But yeah, you know what? Thanks for that. There's three parts of our business model. The first is selling aircraft, right, which is, again, very traditional for an aircraft manufacturer. The second is the aftermarket support. So yeah, supporting those airplanes, part services, training, again, very, very typical. And the third is actually the charging solution. And there's different approaches to charging. There's different ways that you can do it. You can work with directly with the airports. Certainly the people who are buying planes from us right now, or potentially leasing charging applications from us. And we're looking at charging in I'll call it two different ways. The first is, you know, a fixed charging location where you tap it directly into the grid at the airport that you're going to be servicing your aircraft from. That works very well for maybe an operator that has their own terminal where you can reliably park your airplane. But we're also looking at mobile charging. The idea of having a truck that's specifically designed for charging our aircraft that has a battery bank on it, so that you can, you know, again, quickly charge, we call it an e-bowser, a fuel bowser. But yeah.
Maybe a school bus.
You know what? I will say the thought crossed my mind. Yeah.
I'll tell you, we're in the middle of the same tech R&D, and that stuff is hard. It's going to happen, and we're all going to get there. But we're going to power a concert. I won't say who, but a big concert. You would have grown up with them. Part of the concession, which is this big part of it, we're going to be powering it with school buses in the fall. And so I'll send you guys tickets. You'll have to come.
Nice.
Thank you. Yeah, great.
I mean, on that note, I'd love to hear from all three of you. And Greg, you've already touched on it for aviation. But I think when people consider electric vehicles, let's just use Tesla as an example, they think, okay, most of the revenue comes from the sale of the vehicle to the consumer. But also Tesla makes a bunch of money through the software, right, that it sells to those consumers as well. And what the three of you have pointed towards is that there are other business models here, right? So it could be the energy moving back into the grid, but I'd love to hear how each of you are thinking about the different business models that kind of ladder up to, again, a multimodal system for your company, and also where maybe, if you're willing to share, you see the biggest opportunity. Like, where do you see the largest revenue opportunity for your given space?
The way we think about it is, we are delivering better boats. That's our goal. And everything that we are doing at the design and manufacturing side is optimized around how do we deliver a better product to customers. One of the biggest pain points of boat ownership is the reliability and the maintenance burden. So we are at the design stage, and again, through the manufacturing process, designing out a lot of these maintenance burdens. An example is that we have a closed loop cooling system on the Arc 1. It basically uses the hull itself as a heat sink to dissipate heat from the powertrain. And that means we're not ingesting raw water and clogging up filters or having pumps break. Software is also a way to make that experience better. Garmin sells off-the-shelf sort of navigation maps, and that's a $1 billion+ business for them. We want to offer that for free to customers as a way to kind of incentivize adoption of the boats that we're selling, which is still our core business. When we talk about providing backup power to your house, there is a multi-billion-dollar business for backup generators for people's house that we want to go tackle by giving you a boat that you can use to back up your house. All of these are still in support of our core product, which is selling better boats to people at, if customers put on earmuffs, at very good margins. That's kind of the core business that we think about. A lot of the investments we're making go back into driving sales around that core business.
I think I would generally echo some of those themes. I think the market has historically operated in a way such that OEMs are really good at making a product, making a vehicle, whether it's a plane or a boat or a truck, whatever it is. But they tend not to be in the fleet operations business. They tend to sell it to an operator. And that could be someone who buys a car who's just driving around town. It could be could be a waste hauling business. It could be Delta, right? So there are end users that tend to be fleet operators. The business model opportunity that we see is to create more performance-based guarantees around these new vehicle classes. There's a ton of sort of perception out there that it's new tech and so it's not going to be reliable. And there's also a perception that what is this fuel cost? It's electricity. I don't really understand it. My utility bill is very complicated. It's got all these line items that we don't really understand. But so, core to our business model, which we're confident has accelerated adoption in our category and driven the Highland business, is this concept of making it very simple and performance-based. So we will often get paid by the mile. We might charge a customer $3.50 per mile, and they get all the equipment, they get all the services. If the charging station breaks and the bus isn't charged, we just don't get paid. So there's very much an alignment of incentives. And then I think by making it performance-based, we tend to own the assets, and we can then bring on downstream services to increase utilization. Elon Musk wrote a great article recently about how he views autonomous electric vehicles as capable of taking utilization from single digits up to 50, 60, 70%, because all of a sudden you have autonomous vehicles performing tasks and the utilization changes dramatically. So we need fewer vehicles, or we get more done with the vehicles that we have. I believe that's a big opportunity. If you look at garbage trucks, school buses, parks and rec vehicles, any vehicle out there that is not long haul trucking, and you have this dynamic where you can start to piece together other ways to make money or make that asset useful. And if you can deliver it as a service and make it easy for the customer, I think that's where the market's going.
That's really exciting. Just to maybe tack onto the exact opposite end, I think there's an opportunity for people in the infrastructure development business to actually go and start selling solutions to bringing the right electrical services and layouts, and it's almost like an urban planning exercise. But to actually, get the power lines, get the infrastructure set up for whether it's the airport, the marina, or the schoolyard, or wherever you're going to do your charging. That's something that I think we all share. And right now, I know that people come to me to ask, where should I put my charging station at my airport? How much capacity should it have? And so the fact that people are coming to me as the aircraft manufacturer means that there's probably no place else for them to go to get that information right now. I think there's an opportunity for somebody listening to this who's looking to start a business to actually become an expert in doing that, focus their attention on it and start delivering those solutions.
On the note of opportunity, it feels like there are still some challenges in the industry that could be related to regulation. It could be related to the grid infrastructure that exists and needs to be upgraded. It could be the battery technology. Mitch, something you mentioned is potential fear around range anxiety, depending on the product and its needed range, or at least what consumers think they need in terms of range. And so I'll just open it up to the group. What gaps are there for people to tackle, and what would you love to see people tackle? Greg, I love that you've already mentioned one very clear opportunity, but it feels like it's still kind of open range in a way where there's a lot of work to do in the next few years, and I'd love to hear where the three of you are seeing the biggest opportunities, perhaps.
So in terms of aircraft, in the United States, there are 5,000 airports. About 3,600 of them, they have paved runways, nav aids. You can fly a small commuter aircraft like Alice from those runways as a commercial operation. But we don't use 3,000 something airports that way. We use a couple hundred airports with regular scheduled service. And that's actually something that's changed over the past 40 years. We used to be able to fly point to point much more often than we can. But the market, after deregulation, the market, it went away. But even so, if you look at the breakdown of the world's air travel, and it's very similar whether you're in North America or Europe, half of all flights in the world are under 500 miles. And a full 30% are 250 miles or less. watch planes fly by. There's a 30% chance that the plane that you're looking at is flying a flight of less than 250 nautical miles. And the proposition, I think Mitch was mentioning this, so I think we're on the same page on this one. It's a very different thing. Yeah, we're A to B, not necessarily A to A. But if you go back to the whole culture around the automobile, when you get in your car, you want to be able to get in your car and go wherever you want to go, without any concerns. You go, it's open road, it's freedom. It's a great sensation. With an airplane, you want to take off from the airport you wanted to take off from, fly for exactly how long you wanted to fly, and then land at the airport that you wanted to land at exactly when you wanted to get there. Right. So it's a very different prospect. And so there's a wonderful marriage here between what the technology is available today in terms of what we can achieve with range and payload for an aircraft and the way that people actually want to fly. So, our plane today represents, potentially 30% of the total market for aircraft if you look at it. And that's pretty outstanding.
It's such a great point that there's this, marriage between the technology and how people are using this. And I hadn't really thought about the culture around how you approach plane flights, but that's so true. I mean, you before the trip ever starts know exactly where you're going, exactly the distance that you're going, and so you can plan accordingly. If you get out on a gas boat today, it's stuck in the 1980s. Your fuel gauge goes like this. They're super unreliable. Your speedometers don't work. There's no odometer on boats. The state of the art in most cases is unscrewing the fuel tank and looking in and guesstimating how many gallons of gas you have left, and then using intuition to think, how far can I go on this many gallons? And so it is common to run out of gas on a gas boat. That I've done it personally at least a dozen times in my life. And when you think about what you get with an electric boat, suddenly you have down to the percent level precision on how much capacity you have left on that. And you have intelligent software that can tell you this is how far you can go with that amount of battery capacity. And oh, by the way, something that's unique to boats is if you're out in the middle of Lake Tahoe and you have 5% battery, you can reach any other point on that lake as long as you're going 5 miles an hour. It's not a question of if you get back, it's a question of how long it takes. And that is something that's so novel and such a huge improvement from a customer perspective over where things are at with the gas industry today. So I guess going back to the opportunities, I think about it in 3 tiers. There's plenty of these product opportunities. We happen to be tackling the marine space and delivering much better boats to people that happen to be electric. You could look across all these industries and find those opportunities where the technology that exists today, the electric, powertrain delivers a better and more compelling experience to people. And I think, the 3 of us are all doing that. There's also supply chain opportunities. We want our battery prices to be lower. We want our high voltage electrical, powertrain components to cost us less. That helps us a lot. I think there's a tremendous number of opportunities at that kind of base supply chain level. And then there's this third category of what I call second order opportunities. You're going to have an electric future. What does that, imagine what that looks like? Well, you're going to be towing around a bunch of electric boats in electric trucks, or you're going to be towing around an RV in an electric truck. And what does that mean in terms of the new charging infrastructure you need to go support that, or the new technology you need to go make that happen? Maybe it's powered trailers that can actually help the vehicle, or there's just a ton of opportunities. And if you cast your mind forward a few years and think about what are the new problems that are going to exist when all these kind of like the marine industry is going electric and the aviation industry is going electric and the bus industry is going electric.
Yeah. And I think interoperability and standards, industry standards, is a challenge today. And we've left it largely to sort of standards making, traditional industry associations to drive standards. And in my opinion, it's been too slow. We've done integrations with 15 to 20 utility companies in the last 12 months, and every single one of them has been discrete and different. You just have to put the right team on it to know how to navigate the system and get through to the other end. But putting better standards in place would allow for what Mitch is describing. Your boat is charging your house when the power grid is down, or for 4 hours every afternoon when the grid is strained and demand charges are kicking in, or your trailer is charging your vehicle because it's got extra power. That's all interoperability that needs standards. I would flag one other challenge. Mitch mentioned it, but it is one of our greatest pain points, which is supply chains. It's not just about getting the cell cost down so we can deliver cheaper product. It's being able to deliver product full stop. The last couple of years have been really tough on supply chains. It's led to soaring costs, but also just poor reliability. We're one of the largest buyers of medium and heavy duty truck platforms in an electric format right now. So we're talking hundreds of millions of dollars per year of equipment purchases. We're not billions yet, but we will be quite soon. And even as a large buyer, it's tough to get product. And so you've got manufacturing sites that have thousands of completed vehicles, and they are all short an air compressor, or they're all missing, so they can't complete these vehicles and deliver them to customers. And
Preach.
So, yeah, we if we can solve, we are buying switchgear 18 months in advance for projects we don't even have under contract yet, because if we don't have switchgear, we're not getting the infrastructure completed, and we can't get up and running. We don't get paid, and so we're doing all these things that we're solving problems that we shouldn't have to solve, in my opinion. And so I think for some entrepreneurs, there could be big opportunities in streamlining supply chains and creating better standards.
I heard a very creative description of the supply base over the past couple of years, and it was called the surprise chain.
Yeah. That's all you need to say. Perfect.
Okay, here's a timing for what we're doing. You look at the outlook on the aerospace industry right now, in particular aircraft manufacturing, and a lot of the major aircraft manufacturers have already launched their next program, so they're entry into service, they're delivering them. And if you take a look around at the large incumbent aircraft manufacturers, there's no new programs on the docket right now, and the tier one supply base and even the tier two and tier three supply base, they're all hyper aware of what they're going to be working on, and it gives us an opportunity to show, hey, we've got an aircraft, we've got a market, we've got good orders, the utility of the product is there, and I think what's going to happen is that the new technologies that we're bringing and our new products are actually going to garner the attention of the forward-looking supply chain. So I think we're gonna disproportionately benefit, us in the aviation industry, but I think the same is probably broadly applicable. The new technologies, the new companies are actually going to benefit from obtaining the focus of the established tier one, tier two supply base. So I don't want to say the problems are behind us yet, but I think the outlook is actually quite sunshiny.
I'm curious how you two think about this. I know for us, there are incredible advantages for bringing the battery pack in-house, and that's why we vertically integrated our battery pack. It is structurally integrated with the boat hull, in the same way that electric cars didn't become that compelling until you built the car around the powertrain under one roof. I think the opportunity that I see, at least, is on some of the other atomic components that go into a high voltage electrical system. An example might be a DC-DC converter, that when we started ARC, there was one on the market and we did not have much choice. There are now 30 of those, and that's exciting because you can use those across applications more so than you can just drag and drop an entire battery pack. And so when I think about supply chains, it's actually at some of those more atomic components or connectors are a big one for us that have historically been a nightmare. Those are examples of things that work across application and are not necessarily so tailored to your application. So I wouldn't necessarily encourage people to go after, say, building an entire battery pack and trying to make that battery pack work for both boats and airplanes, because that's going to be really hard. We have very different objectives out of what we want from those battery packs. But you might be able to find components that factor across those.
I agree.
Yeah.
You want ballast, right? You want the keel and the ballast to be replaced by battery packs, I'm guessing.
Yes. Yeah. There's, we actually don't mind weight on a boat. It allows you to throw a bigger wake and makes the boat more stable. So we're not as weight constrained as some other people.
Certainly for us, that's a prime example of the difference in some of the design criteria that we've got in the aircraft side versus the marine and land-based applications. But what we've seen in terms of technology evolution is, talking to people, DC-to-DC converters is, by the way, the perfect example for a shareable component that has an important role to play. But I'd like to take it one step further, which is, why do we need the DC-to-DC converter? Why don't we just get the subsystems made to operate at the same 800 volt system level as the rest of the equipment, right? And so we're seeing high voltage applications of traditionally lower voltage electric components coming up. We've got environmental control systems that operate at 800 volts now. Looking at other actuation and so on that operate at high voltage, reduce your wire sizes. I mean, that's what we're pushing on.
Yeah, great point. I would love to see some of these low voltage components actually come up and support high voltage ranges. That would be awesome for us.
Maybe as a follow-up question there, Mitch, you mentioned whether or not you design your own battery packs. How do you think about, given that every single one of these planes, boats, school buses have many components, how do you think about what is inherent to your business and that you build on your own versus buying or borrowing? And then I guess tacking on to that, what I really am trying to get to is this idea of what moats might arise in these industries, right? Like I imagine, let me know if you guys disagree, but like, let's say 10, 20 years from now, we're going to be seeing a lot of electric boats, a lot of electric school buses, a lot of electric planes. And so where does the differentiation come from?
We're just over 2 years old and we are delivering the most advanced electric boat in the world to paying customers. That's exciting. The way that we've been able to do that is by leveraging a lot of the research and development that has gone into the automotive industry over the past decade intelligently and apply it and adapt it to the unique challenges in the marine industry. We're very careful to integrate the things that become the platform for all future boats we develop and try to not integrate the things that do not give us a unique advantage over time or that are more marginal improvements. So the battery packs are core to that moat, and that's hard. It is hard to build your own battery packs. When we talk about moat, we have an incredibly talented team. We have top talent from SpaceX and Tesla and Rivian and other EV companies and marine companies. And it still took us 2 years of working, around the clock to integrate those battery packs and get them production ready for customers.
I just was wondering, do you aspire to be in commercial, boating applications, or is the business, does all that IP you're describing, which sounds very cool, doesn't it all apply when you get into ferries that may have predictable routes? Maybe not long haul shipping, but I don't know.
Our aspirations are that everything on the water eventually becomes electric. And the playbook that we're taking is to start on the recreational side. What we're doing is building a strong brand. We're building a technological moat. We are building an extremely talented engineering team. And along the way, we're driving down our cost of capital because boats are a very good business. And the more boats we produce, the more working capital that we have. And those are the ingredients that ultimately set you up to more efficiently go after larger craft, which I'm not necessarily ready to talk about that part. We have our hands full on the recreational side, but certainly there are aspirations to go there.
I heard yes. Thank you.
We found the sweet spot for making an electric plane. The size of the aircraft, it's a 9-passenger aircraft. It's 9 passengers on purpose because in the United States, you can actually fly 9 paying passengers with a single pilot. We have 2 pilot seats, so you can also use that other pilot seat to train a new pilot, which will help address the overall pilot shortage that we've got. And we didn't do that in isolation. We've come up with this approach based on interacting with real customers and figuring out what they need and what the market needs. The other thing is we're building, it's an electric airplane, but it's just an airplane. So it's a Part 23 commuter category aircraft. That means that we're building it to be certified under the existing standards. The pilots who fly it will be able to fly it with their existing pilot's licenses. They get trained the same way as they would for any other aircraft that size. Likewise, with the mechanics and people who operate the aircraft on the ground and maintain it. It's the same system that we've got today. Flies from existing airports using the existing airspace, right? So we've got this product that's being fit so that we don't have to go and change the way that aircraft are certified. And it's the other way around. What we're able to do is say, look, we've developed an electric airplane that meets all of these standards, right? So our plane meets the same standards as any other airplane in its category. And to the point of mass adoption, 100%, I firmly believe that in the next 10 to 15 years, we will all be flying regularly on electric airplanes.
I have aspirations to get my pilot's license. And one of the things that clicked for me is the biggest risk to being a pilot and flying, a Cessna is reliability of those vehicles and the number of checkdowns that you have to do on an aircraft before it gets into the air. In my mind, it makes a ton of sense. Like electric aircraft make a ton of sense because you get that extra reliability, almost for free, that you're no longer worried about the whole class of problems you worry about with mechanical engine failure on an aircraft. So I am personally excited for that future. I want to fly an electric plane.
I aspire to visit Greg and have him take me for a flight in his plane.
Me too.
Yeah, you guys can all rotate. You
we
can
should
get,
do a pact. Yeah,
I was going to say,
that.
go out
I'll
on the
host everyone
boat.
for a boat demo. Yeah.
Everyone's going to the concert.
I would love it. I can ski a little bit.
Awesome.
Great.
Yeah. Steph, your question on differentiation, these guys obviously have, products that have had a ton of IP investment that's truly, technical IP behind the product. We're a really different business. We buy a finished product for the most part from leading OEMs, and the business model that we're running is really bundling and packaging of services and financing. And if you look at the big solar operators, companies like Sunrun and other utility scale businesses, they drove commercial adoption, and that's because they very elegantly bundled and packaged a whole bunch of services with capital, and they made it very easy for customers to adopt. And so we're very much in that business. It's lots of little things, from training mechanics to training drivers to building a technology backbone that's scalable so that we can actually operate these fleets relatively efficiently. But I think one of the things that we've identified as a core differentiator for us right now is simply scale. We're the largest provider in this space. We have more contracts and bigger contracts than anyone else. And when you look at scale, especially in the early days of the market evolving, we have better access to capital, cheaper capital. We have more miles under our belt to prove to that capital that we're a reliable operator. We can buy product at scale and get better terms in buying everything from charging stations to switchgear to construction services. And then because it's local, we have operators on the ground that are responsible for actually delivering some of those services. Some of them are really technology driven, but some of them are people on the ground who actually have to turn some wrenches. And we have scale in places like Maryland, Michigan, New England, where it's much cheaper for us to operate and add that next customer than it is for our competitors. And so I think those are some of the moats we're building, but very much believe that it's a more challenging bundle of services than operating a solar farm. And that's going to continue to be difficult for others to replicate.
Absolutely.
My synopsis or summary of Duncan's point there is ideas are cheap. The hard part is execution. Mm-hmm. I'm sure there are 1 million people in the US that have thought somebody should make a Tesla for boats. The hard part is, how do you go build a product that can actually deliver that vision? How do you go package enough battery on a boat to make it compelling in such a power hungry market?
Totally agree.
How do you do that without, spending incredible amounts of money on CapEx or R&D? That's the hard part. And I think that speaks to the moat here is it is hard to go do this.
That's amazing. I couldn't have said it better. I completely agree with that. But I also just want to pick up on one point that Duncan just made, which is very, very important. It's the order book, right? Having a real order book where you've gone and sat down with the customer and they've said, yes, we want your product. We at Eviation recently passed by the $3.5 billion pre-order mark, right, for the aircraft. More than 400 airplanes on LOI that we have with our customers now. And they're real customers. These customers that are signed on early are committed to working with us on the program. They're giving us feedback. They're giving us information about how they're going to actually operate the planes. And then they're there to work with us, to be our launch partners when we actually put those planes into service with them in the next few years. So I just want to emphasize that order book says so much about what your market is saying. And then recently we just announced a deal with the leasing company, and because the leasing company doesn't just bet on aircraft on our aircraft. The leasing company is betting on the market. And so it's telling you that there is a market for your entire product line when a leasing company buys it. It's very, very important to look at that mix.
I should share that we chose the three of you to contribute to this conversation is because we did do our research and checked that all three of you have orders booked. That was really important in terms of you're actually on the ground, you have relationships, and to all of your points, it shows that this is not just an ideal where we want to electrify and eventually people will buy into this. The market is actually participating in this. They're saying, okay, the cost combined with the other benefits that we're seeing in this industry now are actually better, to the point that we're ready to put our wallet down. And so that was really important in terms of us determining, again, there are many participants in all three of these spaces. And so that was essential for us. But I also want to just quickly note that all three of you spoke to so many different opportunities for moats. There was technical moats, there was operational moats, there's even potentially regulatory moats. And so I think it's fascinating to imagine how this develops, right? Because there's not just one single moat. Each one of you are figuring out where your business tied with your customer base, whether it's B2B or B2C, what they're really looking for. That's amazing. I think one great place where we can end this conversation is we've already kind of spoken to this idea that this is where these industries are moving in 5 years, 10 years, 20 years. We do expect these set of industries to change and to be electrified. And so I'd love to hear the three of you just comment on what that really means, contextualize the impact of, let's just say, maybe not all aircraft, but most aircraft being electric, most boats being electric. I know this will take time, but I'd love for the audience to just understand maybe the second, third order effects or the implications of that shift once it's fully manifested.
I think something that some people don't necessarily think about is the next generation of boaters will not be allowed to use gas boats on our lakes and rivers. They are very unpopular because they're huge polluters. Semi trucks out on the water, except a lot of them don't even have catalytic converters on them. And so you just see these fuel slicks behind boats as they take off and all the noxious fumes around there, CO2 poisoning warnings on the back of these boats. Fast forward several years, you're looking at marinas that are quiet, that have clean water around them because these boats are not polluting into them. We'll take an Arc One out into a marina and we'll pass a sailboat, and the sailboat will be louder than our boat. So just this ability to suddenly appreciate and enjoy water so much more than you're able to today with kind of this drum of engine noise kind of drowning everything out it's an exciting vision that we're driving towards.
When you look at urban areas around the country, the EPA has, you can go to their website and look up who's in attainment of air quality that's fit for being healthy for human life, is effectively the way they describe it. And most of our major cities do not meet the threshold. And it's because we have tailpipes from vehicle traffic. We've essentially moved all of our power plants further outside of urban areas. We don't run coal plants in cities anymore. And so bad air quality is a function of tailpipes. And cancer rates of pediatric asthma are high in cities where tailpipes and vehicle traffic is high, and areas where the airflow does not wash those fumes out quickly and easily enough. And so there are places in California where we're engaged with municipal leaders where pediatric asthma is over 30%. And so our vision is tackling air quality at the local level, tackling climate change at the same time, creating a very clean, quiet, urban future. And Mitch said quiet. We would say the same thing. Our bus depots are silent, and the buses operate almost entirely silently. Trash pickup could happen earlier in the morning because you don't have the loud rumbling noises of a diesel engine. And the grid is not utilized to the tune of 36% or 38%. It's utilized to 55, 60, 65, 70%. And so we can integrate more renewable energy, not less. We can reduce demand charges and just charges to ratepayers, and create an ecosystem where transportation of all forms, whether it's flight, marine, or road, is really integrated into an energy ecosystem that's more efficient, cheaper, and better.
In the near future, you're going to be able to take a 10-minute trip to your nearest airport, get on an airplane, and fly for an hour to do a day trip that previously would have been an overnight trip or a trip to an airport half an hour, 45 minutes away, and through going through security. You're going to be able to conveniently move from point to point to go do the trips that you want to do. They'll be more time effective. It'll be good for the economy in terms of enabling more trade, but also in a social perspective, just being able to go and see people that you want to be able to see. We thrive in connectivity. This type of connectivity will disproportionately benefit small rural communities that previously have not had the benefit of having air travel, which is a real economic motivator. These flights will be much more cost effective than the flights we have today because they eliminate aviation fuel and replace it with a much cheaper electrically derived energy from the grid. As with those other forms of transportation, electric aviation is very quiet, which means that not only will you be able to increase the frequency of flights or even add previous flights that just haven't existed in decades, you'll be able to do it not worrying about polluting the environment, but also not worrying about irritating your neighbors because the flights will be so quiet that nobody will complain. In fact, you will want to have that airplane next to you so that you can take advantage of it. It's going to change the way that we fly. It's really, this is the future.
I'm just picturing this summer day in my head where you wake up, you go to your nearby airport, you fly to your friend who lives near a lake, you go out on an electric boat. After that, you go to a concert powered by an electric school bus. And I'm just, this is obviously an extreme scenario, day. But you know what? It's the perfect day that is hopefully enabled by technology in the coming years. So
it's not far off. Yeah.
We're counting on you guys. Let's make it happen. I think that's a great place to end off. Thank you so much for sharing the amazing things that all three of you are building in your respective spaces. And I think it was fascinating to just see the overlap and also some of the differences that are unique to your industries.
Thank you for the excellent questions. It was really inspiring and thought-provoking. And Duncan and Mitch, that was really enjoyable. Thank you both.
Yeah, I would echo. Steph, thanks for getting us together, and Mitch, Greg, love to stay in touch with you guys. Love what you're doing.
It'd be a pleasure.
Yeah. Thank you for having us, and it's an awesome and inspiring conversation. I look forward to experiencing both of your products myself.
Thanks for listening to the A16Z podcast. If you like this episode, don't forget to subscribe here on YouTube to get our exclusive video content. We'll see you next time.